In this, hopefully, quicker video, I'm hoping to talk to you about what domain and range are. And the first thing I need is I need to clear something up a little bit. I feel like when we write domain, you guys know what domain is. X. And you know what range is. Range is Y. I'm not even going to draw my pretty Y for that one. Domain means X, range means Y. And I see where we get that from, but domain and range mean more than that, right? And in this video, I want to talk more about what they really are. So first, domain. So the domain of a function is basically the set of all of the x values that can possibly be substituted into a function. In other words, it's the set of all possible inputs. It's the set of the things that you can legally plug into the function, right? Similarly, we can talk about range. So the range of a function is the set of all y values that can be obtained as outputs from a function. So some of you are sitting at home going, say I was right. It's x and it's y. Yeah, okay, I get it. But I want you to understand that it's a set, right? These things are sets. That's why in your other classes they had you use these sort of like set notation brackets, and they would say the set of all x such that blah blah blah, the set of all y such that blah blah blah. They were trying to tell you the set of things that can be inputted or things that can be obtained as outputs, okay? In this video I want to talk to you about how we can determine the domain and range of a function. So the first and easiest way to determine the range of a function is to think about its graph. The graph does not have to be perfect. In fact, I purposely picked an ugly one here so that we could talk about it, right? So I want to know if you can mentally come up with a picture of what this graph looks like even incredibly roughly. Like just kind of think for a minute, like, so what does this graph look like, right? This graph has been shifted up 1. The 3 in front means what? The 3 in front means that it's taller. The -7 here means it shifts to the right. And if you fully understood the previous video, how much does it shift to the right by? Hopefully you recognize it shifts to the right by 3.5, because we do the 7 divided by the 2. And this 2 here effectively means that the graph is narrower. Okay? So if we tried to graph this thing, right? Here's what I would know, right? I know that this graph has to be shifted up by 1, and so that's sort of where my equilibrium line is for this function. I know that I'm supposed to go 3 above that and 3 below that, so my graph never goes above this and never goes below this. And then there's some business about the graph being shifted, to the right by 3.5 or something, and then it's narrower. Like, the graph is going to look something like this, right? And some of you may be going like, whoa, does that really count as a sketch? If the problem was sketch, not really. But all I'm asking you to do here is find domain and range, right? The domain is what is the set of all x values. So look at this graph, and this is the important part. This is the key to this whole example. Look at this graph. How far does this graph go to the left and right? In other words, like, where are there points and where are there not points? Would you agree that there is a point for this graph for every single x value? In other words, I can plug in anything. What that means is, it means that the domain of this function is basically all real numbers, right? Now let's talk about range. Range is supposed to be what is the set of all possible outputs. In other words, what possible y values are you allowed to get out of this function? And the answer is not all real numbers. Look at the graph and think, what y values are you allowed to get out? Am I allowed to get a y value of 0? Sure, it happens here, 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 here. It happens lots of places. Am I allowed to get a y value of -2? Sure. Here, here, here. Am I allowed to get a y value of 7? No. 7 is up 3, 4, 5, 7's like the graph never gets up into that range, right? Because of that, we know that my range is the set of all y such that, now look at where the y values are. The y values go as low as -2 and as high as 4. So this is the set of all y such that -2 is less than or equal to y is less than or equal to 4. And that's your range, right? I feel like if you've got a graph of these things, it's actually pretty reasonable to find what the domain and the range are. So with that said, here's an example of one of these for you to think about, right? I want you to pause the video, think about how you would graph this function. I mean, like, hopefully you can figure that out. It's worth it for you to think about what this 5 means, so make sure you think about that. Come up with a rough graph of this thing, and then come up with what the domain and range are. Okay, so what these things mean. The 4 means that I'm going to the left by 4. The 5 means I'm going up by 5. And the 3 basically means, well, it's negative, so I'm flipped upside down and it's taller. So I'm going to the left by 4. I'm going up 5. So this is sort of my starting point. And then I basically have a downward shaped square root graph from there. Right? So now that I'm looking at this, what can we say about the domain of this function? What can I say about all possible x values of this function? Well, if you look at where all the points are, the points start at -4 and go larger than that. So it's a set of all x such that x is greater than or equal to -4. Right? And I'm hoping that you can do the same with range. Pause the video, think about what the range is going to be. Well, it's the set of all y such that, notice the highest this graph ever goes is up here at 5. So it's the set of all y such that y is less than or equal to +5. If you have a graph, finding domain and range should be incredibly easy. That's the purpose of these two examples. Sometimes, though, you won't have the graph of a function. Sometimes it's some function you're not familiar with, you haven't seen before, you've got to come up with some other way to do it. The hint that I'm going to give you is that sometimes it helps to just think about what a function can't do. Like, sort of think about, like, you're not allowed to divide by 0, you're not allowed to take the square root of negative numbers. And when you have those things in mind, think about your function and see if you can think of what things you're allowed to plug in, right? So for this function here, right, let's try and figure out what the domain and range of this function are. We know that a square root can't be negative. So we have to sort of think, like, what could possibly make the stuff inside 16 minus x squared negative? And pause and think about that for a second. If x was bigger than 4, or I suppose for that matter, if it was less than -4, that would cause the inside of that to be negative. That means to me that my domain sort of tells me, so what do we know about x? X has to be bigger than -4, but smaller than 4. X basically has to be in between -4 and 4, right? Now range is, again, things get tricky, right? You sort of have to think here, like, how big could y get? Like, how big and how small could y get? Well, could y ever be negative? It can't be negative because the square root's going to give you back a positive value. It could be 0 because you could plug in 4. What's the largest this y value could be? Like, pause and think about that for a second. The largest that value could be is 4, right? I mean, if I were to plug in 0 there, I think I made a mistake earlier. You'd have to plug in 4 to get the 0. Whatever. If you plug in 0 there, we'll get the square root of 16, which is going to give us 4. It's hard to see these things when you're just thinking about them, but sometimes it's what we have to rely on. Sometimes we have to deal with things like this, right? One final comment here. This one is special. It's another graph that I kind of think you should know, only because if I square some things and move them around, you might recognize it. If I square both sides, I get y squared equals 16 minus x squared. If I add the x squared over, I get x squared plus y squared equals 16. You might recognize that as a circle, right? And so when you take the square root of it, what you end up with is you end up with the top half of a circle of radius 4. And from the picture, you can totally see, hey, check it out. The domain goes from -4 to 4, and the range goes from 0 to 4. So that's what I mean, again, about the graph making it really easy to tell what the domain and range of a function are. So the last example I have, and this is a harder one, but it's one that I want you to be able to think about on your own. See if you can figure out what the domain of this function is. You could try and find the range also, but it's kind of funky, so I don't know that I would worry yourself with it, but at least figure out what the domain of this function is. So if you need a hint, you're thinking about what is this function allowed to do, specifically what is it not allowed to do, right? The inside of that square root can't be negative, and the inside of that square root better not be 0, because if it was 0, you'll have division by 0, right? So in order to keep the inside of this thing positive, like that x squared has to end up being 9 or bigger. So to me, that means x has to be bigger than 3. And if you think about it, bigger than or equal to is not going to cut it, because you'll end up with division by 0. So we have to have x being bigger than 3, or we have to have x being less than -3. And so those two things together effectively determine the domain of my function. Those two things will give me the domain of this function. Range is a lot harder. I'm not going to try and explain it in this video because, to be honest, it's not super necessary, and the video is already running long as far as I'm concerned. I'll go ahead and tell you what the range is. The range for this function should be the set of all y such that y is greater than 0. You can obtain any number greater than 0 out of this thing. You would obtain really, really large numbers by plugging in numbers that are barely bigger than 3, and you could obtain really, really small numbers by plugging in very, very, very large numbers for x. So if you want to think about that, if you want to think about what the range is, that's what it is. But I'm not really expecting you guys to be able to come up with a range of strange functions like that.